Hello everyone. So in this video, we are going to see Sumpner test or something called back-to-back test that is related to transformer. So after watching this video, we should be able to answer these questions like why this Sumpner test is required and what are the advantages of this Sumpner test. Okay, so before I start with the Sumpner test, you must know few basics. Like if I take transformers, in case of transformer, you can perform several tests. Like there is something called polarity test. There is something called open circuit test. There is something called short circuit test. So majorly we do this sort of tests in general. So the thing is, if you see in case of open circuit test, we consider only shunt branches in the from the equivalent circuit point of view of the transformer, and the open circuit test gives the information about core loss. Okay, by the help of open circuit test you can calculate the shunt branch parameter. Like in the with the help of open circuit test you can calculate the magnetizing inductance of the core and core loss resistance of the core. Okay, these are the components that you can one can calculate from the open circuit test, and the power loss is nothing but the core loss here. The whatever power loss we get from the open circuit test, that actually represent the core loss that is happening in the core of the magnetic material. This is about the open circuit test. Now, if I talk about the short circuit test, in case of short circuit test, we get the copper loss, okay, winding copper loss, and in that case, we actually neglect the core loss of the transformer. So, the thing is, we have two tests, open circuit test and short circuit test. One is giving core loss, another is giving copper loss. But the issue is, we are not performing these two tests simultaneously. Like, for example, in practical scenario, both the losses will occur simultaneously, and if both the losses occur simultaneously, the impact of the both the losses will be different. Like uh, the losses, whatever losses will be there in transformer, that will give rise in the temperature in the transformer. So the temperature increment we cannot even calculate if we consider copper loss and core loss separately. But in actual scenario, this core loss and copper loss will happen simultaneously, and that will give uh, a huge temperature rise in the transformer. Okay, that actually we cannot even get from open circuit and short circuit by doing separately. Okay, now the thing is, if you really interested to know the what is the temperature rise of a transformer, then let's say you want to know the full load losses, full load core loss and full load copper loss, then you can do one thing. Like if you have a transformer, then you energize the transformer and you can connect the load at the load terminal, the rated load you can connect, and you can maybe measure the uh, like what is the power that is going inside and what is the output power through the wattmeter and all. Like you can measure the input power and you can measure the output power, and in that condition you can also check what is the losses that is happening inside the transformer. Okay, but the condition is you have to connect a load. You have to connect a load, but this, by connecting a load you can know the temperature rise of the transformer, losses in the transformer. But think, like if your transformer size is very high, like it is a 100 MVA transformer, in that case, to like what do you say, to connect a 100 MVA rated load is not a easy job, right? It is a huge task to connect a load 100 MVA to transformer to test the temperature rise of the transformer, losses and all, like. So here the issue here, Sumpner test comes gives a great advantage actually. Without even connecting a physical rated load, by having two similar transformer, you can calculate the core loss and copper loss at rated conditions. What is the happening in the rated condition? Okay, so that those are the advantages basically. Without connecting uh, a rated load, you can get the information how much core loss is happening, how much copper loss is happening, and because of those two losses, Definitely, if you keep your transformer in the back-to-back test for few hours or few maybe 4 to 5 hours, or it depends on the transformer, you will get the temperature rise in the transformer. So we will see how this Sumpner test is performed. Okay, now let's see. Let's say let's say you have this supply. Okay, you have this supply and you have two transformers with you. I said like for back-to-back test, the main requirement is to have a unique transformers, like trans ratio of the both the transform must be same, and specification and all are the similar. So if I connect this two transformer parallelly, let's say if I connect this two transformer parallelly, okay, let me write it here. This is my source. This is my source. Here I have wattmeter. This is my current coil. This is my pressure coil. And maybe can remove slightly further. This is my wattmeter one. Now you have some voltmeter to measure the supply voltage. Maybe you can also have some ammeter here to measure the currents. Okay. Now you can do one thing. So connect this to transformer, the secondary side. Let's say you are bringing this terminal here, here. Okay. So if I connect series, the non-dotted terminal, then what will happen? Let's see. Your supply is there. Okay. So your secondary side is open circuited. So some current will flow through the transformer. Okay. Now let's say these two transformers are identical. So transformer one is drawing exciting current of IE1, IE. So since both the transformers are same, so it will also draw exciting current of IE. And the current that will come from here, it is 2IE, exciting current. Okay. And if you see the secondary side, let's say this is terminal your Vx and this is terminal Vy, and this is your plus minus polarity, and this is your plus minus polarity. So if you try to calculate the loop voltage, let's say Vx, maybe this voltage is something I'm giving name as E2, and it is also E2 because both are identical, right? If it is N1 is to N2, it is also N1 is to N2. So Vx minus E2 plus E2 equal to Vy. So like both are in equipotential. The both the point that are the output terminal both are in equipotential. So no, and this is the point that will require the later explanation. You'll keep in mind that this Vx and Vy are the same potential. Okay. Now this exciting current cause a core loss. Okay. That core loss can be recorded with the help of this wattmeter, because since there is two transformer connected in parallel, so the wattmeter reading will be 2 times of P core loss, and both the transformers are identical, so it will record twice of the core loss that is happening into one transformer. Okay. Now core loss, we got the core loss data. Now let's say we want to calculate the copper loss data. So for that we can do one thing. We have, let's say, auto transformer with us. Okay. And we have ammeter. Maybe you have some voltmeter also. This is your another wattmeter W2. W2 connected like this way. Okay. And let's say you are interested to know the full load copper loss. And this is again, this is your supply side. So you can vary this tapping to generate the full load rated current. Okay. So let's say your full load rated current, let's say you have adjusted the tapping such that you got a full load rated current, and that is something I2, maybe since it is following secondary side, so I'm calling I2R rated current. Okay. Now we will see the direction of the currents and all. Okay. Let's see. This I2R current will flow. It is entering into the dot. So the reflection of the current, this primary side, that is I1R, the I1R will leave the dot. Okay. Now come here. The another transformer I2R is flowing. I2R, I2R, I2R. So it is leaving the dot I2R. So it should enter in the primary side. So it is, I'm calling it as I1R. Okay. So you can see this I1R, it is flowing here, here, and here, 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 here. I1R is trying to complete the path within these two transformer only. Okay. So this I1R is not even getting recorded by this wattmeter 1. Okay. So this primary rated current will be flowing within those two transformer only. Okay. And you can see, because of this I2R, it is flowing through the copper or copper winding. So it will give the copper loss. So the copper loss will be W2 2 times of the PCU. Okay. Because see, it gives a great advantage. You need not to even connect a physical load to calculate full load core loss and copper loss. You have this 2 wattmeter supply, this ammeter, voltmeter and all. You can adjust the voltage to get rated voltage such that you can get the rated core loss. Also you can vary the turns ratio to uh, to get the rated current, and with the help of the rated current you also can get the rated copper loss. But the thing is, both the W1 and W2 will calculate core loss and copper loss for both the transformer. Once you know like the core loss or copper loss measured by the watt meters, you can simply divide it by 2 and you can get the core loss and copper loss that is occurring in the both in one of the transformer. Okay. Here now at this condition, at this point, your transformer is operating at rated condition, and you are having both the losses. So you can keep this connection for several maybe few hours until your temperature rise of the transformer gets steady. So you can also check under rated condition what will be the temperature rise in the transformer, because temperature rise gives it is a crucial point from a design engineer point of view. If the temperature rise is too high, then the whatever insulation you are using in the transformer, the breakdown voltage will also reduce. Okay. So from that point of view, it is important to know the temperature rise and all. So the Sumpner test gives us the freedom to calculate the actual scenario or to simulate the actual behavior of the transformer without connecting a load. Okay. Yeah. Thank you. If you have any doubt, you can ask in comment section. Thank you.